Okay, you're asking about constitutional isomers of things like C3H7Cl. All right, I'm going to give you a brief rundown of how we can identify this, and then we're going to take it a step further and add some more chlorines and more carbons to this. All right, but very first thing we want to do when we figure out how many constitutional isomers there are is just really look at what we can ignore. Like, for instance, we almost always ignore the number of hydrogens. We're going to take them into consideration here in just a second, but hydrogens always go on the outside. They just fill up the spaces. And for the most part, your halogens do too. About the only time halogens do anything weird, like form two bonds of a single atom or whatnot, is if there's an oxygen involved with them and they're making like polyatomic ions. That's very rare, and it'll probably be described somewhere in the problem that they do. Otherwise, you're going to treat that chlorine like a halogen or like a hydrogen. All right, so really, we just need to worry about arranging those three carbons, which makes this one very simple at first, because there's only one way to arrange three carbons. They're just in a straight line. Now, theoretically, they could be a ring, but I'm going to show you here in just a second how we can prove that they definitely are not in a ring. All right, so they're going to be just three in a row. And then after around all these other locations, remember how carbon likes to make four bonds, that's where we're going to end up putting those hydrogens and chlorines. Matter of fact, we notice there's 1, 2, 3, 4, 5, 6, 7, 8, and there's 8 remaining atoms. Well, it turns out what I just actually showed was how I knew carbon, this particular thing, had no rings or double bonds. We talk about it and we call it the elements of unsaturation. It's really telling how many rings or double bonds there are. And all we can do, at least at first, the easy way to see this is to know the potential hydrogens that are in there. What I mean by that is if you have 3 carbons, like we do here, the potential, or the most number of hydrogens that there can be is twice that plus 2, which is 8. That's actually all these possible locations. If it was less than that, and it'll go by 2s, if it was only 6, then we would know there was a double bond somewhere, or a ring. But since this had those 8 spots, I knew there were no double bonds and no rings. I knew it was a straight chain, so I just had to put those 3 carbons in a row. And you'll be expanding on that later, because that'll help you identify double bonds and triple bonds later on. All right, but we know in this case we had nothing but carbons and hydrogens, single bonds, and then that 1 chlorine. All right, that makes the constitutional isomers here kind of easy to figure out, because the 7 hydrogens, I'm going to put them all indefinitely last, so the only thing I need to worry about is the 2 locations I could put the chlorine. Because see, I could put the chlorine here on the end, and then everything else is just a hydrogen. And now we just have a chlorine on the 1 position. Now if I put it over here and place one of these 3 hydrogens on the right, it'd still be in the 1 position. We're just going to number it backwards. So the chlorine can be on one of the N carbons, or the chlorine could go in the middle. And that's it. That's really the only 2 ways of doing this particular molecule. And it is kind of a trial and error. You're going to figure out all the different ways to do the backbone, and then figure out how many other locations off that backbone are equivalent. And in this case, the 2 ends were exactly the same, and the middle was different. All right, so let's take this a step further. I'm going to add 2 more hydrogens to this, 1 more carbon, and another chlorine. So how about we just add 1 carb? Yeah, let's do this. How about this? Make it better. How about C4H8Cl2? Now, I went with a grand total of 10 on the hydrogens and chlorines because that's twice the number of carbons plus 2. So I know this has no double bonds and no rings. It's just a straight backbone of carbons. All right, so to figure out my constitutional isomers, I'm going to start with just looking at the carbons and figuring out how many different ways I can arrange 4 carbons. The easy one is 4 in a row. But that 4th one, I could put off the middle, and then I could have 3 in a row with a carbon. All right, that's the only 2 ways I could do the 4 carbons. But now we have all the different places we could put the 2 chlorines. All right, because even if it was just one, I could put a chlorine here, or I could put a chlorine there. Going to be a lot of these, because after those 2 locations for just one carbon, I also have to worry about, well, where is the other chlorine? Because there's 2 chlorines. Because I could put them both on the same location. I could put one on the first one and one on the second. Could put one on the first and one on the third. I could put one on the first and one on the last. You notice how so far all these are different. And I am intentionally leaving off the hydrogens. They're just in the way on these drawings now. All right, that's all the locations I could do if I have a chlorine on that first carbon. Got a 1,1, I have a 1,2, I have a 1,3, and I have a 1,4. All right, there is still another one here, or at least one more, because I could have both chlorines on that second location. And now there is only one more that is actually unique. Second location and the third location. Because if I try second and fourth, that's the same as the first and the third. If I do third and third, that's this. So this is all the ways I can do that straight chain with 2 different chlorines. Quite a bit, huh? All right, now, over here, we have that same problem. I could put both chlorines on one carbon, or I could put both chlorines on 2 separate external ones, or I could put the 2 chlorines, one here off that same top one and down here. Now every other possibility here you're going to find is just a duplicate of it. All right, but the key on this is just to practice. There's plenty of practice problems in the textbook, so give them a try, see what you can come up with. The bigger trick is to actually learn how to name these as well. And then we're actually going to throw stereochemistry in here, because it turns out things like, well, which one for sure? We can say that position right there, how that chlorine goes on changes the rotation of that molecule. That is actually a different type of isomer, or an additional type of isomer called a stereoisomer. All right, let me know if that helps.